Hello everyone, my name is Demetra De Cicco and I am a Fondesit Fellow at Pontificia Universidad Católica de Chile. The work I am presenting today is dedicated to the development of an automated, reliable and efficient methodology to find AGN via their optical variability, in view of the wide field surveys to come and especially the LSST. Our analysis is focused on the Cosmos field, which is one of LSST's deep drilling fields. We make use of data from the VLT survey telescope, and our dataset is at present one of the few that can take advantage of both dense sampling and an extended baseline, together with a considerable depth. The surveyed area is of 1 square degree, and we have 54 visits over 3.3 years in the R band, with a single visit depth of 24.6 magnitudes. In this work, we use a random forest classifier to select a sample of optically variable AGN candidates. To build our classifier, we use a set of features consisting of classic features describing variability, features for time series analysis, a morphology indicator, and a set of 5 optical and near-infrared colors. We define a label set of sources consisting of AGN and non-AGN. Non-AGN includes stars and inactive galaxies, while for the AGN category, we choose samples of objects selected on the basis of different properties. We have a set of type 1 and type 2 AGN confirmed via optical spectroscopy, plus a set of AGN selected via their mid-infrared properties from the color-color diagram proposed by Donnelly et al. In 2012. We make a number of tests using different sets of features as well as different label sets, and build each time a different classifier with the aim of understanding which one works best for our study. The top left figure here shows the confusion matrices obtained for different classifiers, where we always use variability features and progressively included 2 to 5 colors. We find that the addition of colors to variability features allows us to confirm a slightly higher fraction of AGN with respect to the fraction confirmed when using only variability features to build the classifier. On the contrary, using only color features, we obtain very large and highly contaminated samples of AGN candidates. Our results confirm that variability selection returns redder AGN candidates than those in the label set, as you can see from the top right panel. In general, variability is able to retrieve host-dominated AGN rather than the samples obtained using only color features. AGN with red colors can be confused with inactive galaxies, so variability selection has a great advantage over color selection, which typically fails in their identification. We also make a test using a bright selection of spectroscopic AGN with magnitude lower than 21 as a label set. Indeed, in the next years, the samples of faint spectroscopic AGN available to build label sets will be rather poor, and so it is important to assess whether a bright label set affects the obtained sample of AGN candidates. As you can see from the bottom panel, the results are encouraging, as the 2 samples of AGN candidates obtained using the full depth AGN label set and its bright subsample do not reveal any significant biases nor peculiar properties. We also test the inclusion of an additional feature, the mid-infrared color, defined as the magnitude difference between 4.5 and 3.6 micron. This is the only non-optical feature used here, and we find that its role is not essential when only type 1 AGN are included in the label set, while it becomes more and more relevant as type 2 AGN are taken into account. You can see this from the 2 panels here. They show the ranking of the importance of the various features used to build our classifier, where the full label set of AGN is used for the training. In particular, the panel on the right corresponds to the test performed with the inclusion of the mid-infrared color, and you have certainly noticed that this color is way more important than all the other features. This happens because this feature helps disentangle obscured AGN from non-AGN. We find that the best classifier among the ones we tested is built using the full set of features and only type 1 AGN in the label set. The obtained sample of AGN candidates has a purity of 91% and a completeness of 69%. This corresponds to a 5 and 10% improvement with respect to the purity and completeness estimates provided in De Cicco et al. 2019, where we adopted a traditional approach to select optically variable AGN candidates from this same dataset. This table summarizes the main results obtained for the tested classifiers. You can see that in order to obtain a pure sample of AGN candidates, the best AGN label set is the one including only type 1 AGN, so a pure one. Conversely, a heterogeneous label set including AGN selected via different methods will lead to a more complete sample of AGN candidates. Finally, from this work, we provide a lower limit for the AGN sky density expected for the LSST. Our 344 AGN per square degree translated to 6.2 million AGN expected in the 18,000 square degree area of the LSST main survey, down to our current magnitude limit. Thank you.